Rick Jones recently came across this old picture of Jamie Throckmorton standing next to his dirt late model after winning the feature at the Tucson County Fairgrounds in the 1980s. Back then, Steve Scheick, from Performance Engine and Machine in Tucson, Arizona, was building a lot of winning engines, including Jamie's, and Rick's cam company, Dick Jones Racing Cams, was starting its second year in business and grinding cams for a growing number of engine builders while grinding all of Steve Scheick's cams. And the only copies of Rick's cam software were on his computers. Curious to see how smart they were or were not in those early years, Rick contacted Steve to dig up some 38-year-old 410 cubic inch late model engine build and dyno sheets. We'll read the components and values from the build sheets for you, as they are already entered in the induction logic software. This is what they had. The blocks were high nickel bow ties with a 4.155-inch bore. The crankshafts were Callies with a 3.75-inch stroke. The rods were Oliver with a 6-inch center distance. The pistons were J and E with a 1.125-inch compression height and 8 cubic centimeters dome volume. The pistons were at 0 deck. The block deck was 9 inches. The head gasket compressed height was 38 thousandths and did not give gasket bore diameter, so they entered a common value of 4.185 inch. They used ported All-Pro 227 aluminum heads with chamber volumes of 64 cubic centimeters. The heads had 2.125-inch intake valves and an intake port volume of 244 cubic centimeters. They had 1.6-inch exhaust valves, and both valves had 341 thousandths valve stems. They didn't record, measure, or calculate port lengths, minimum cross-sectional area, or average cross-sectional area. At 500 thousandths valve lift, the intake port flowed 296 CFM and the exhaust port flowed 218 CFM. At 725 thousandths valve lift, the intake flowed 335 CFM and the exhaust flowed 242 CFM. The intake manifold was a ported Super Victor. And Steve's longtime friend, Dave Braswell, built the methanol annular discharge 980 CFM carburetor. The rocker arms were 1.6 ratio, stainless, 7/16 stud mounted, crowers with an aluminum rev kit. And they used 80 thousandths wall pushrods. The intended peak horsepower RPM was 6,900 for this engine, but we'll use 6880 to make everything agree. All of the roller cams ground for Steve were inverse radius rollers with 2.5-inch to 2.9-inch minimum negative radius of curvature. This cam's intake profile was 300 degrees of duration at seat, with 308 on the exhaust. The lobe lifts were both 425 thousandths. They were ground on a 108 lobe separation angle. Using today's software, you can see how close the camshaft requirements are to the camshaft designed and used 38 years ago. But when we check the horsepower, we find the calculated numbers are much higher than the 734 horsepower recorded on the dyno. But Rick and Steve both knew exactly the reason for that, and we'll model it for you on the software. The .02 thin pushrods with a little help from the stud-mounted rockers allowed over 45 thousandths valve train deflection. So we will lower the VE percent until the intake valve lift is 45 thousandths less. Now we can get a relative horsepower number of 739. It is amazing how you can use this software. Induction logic also displayed 630 pound-feet at 5210 RPM, while the dyno results were 612 pound-feet at 5300 RPM. When Rick started designing cams, he had been using 100% VE and 300 feet per second port design velocity, as his father had taught him. In fact, Dick's equation had no input for mean port velocity, as it was fixed in the math at 300. So, the first cam Rick sent Steve was a 320 with 424 thousandths lobe lifts. It peaked horsepower at 7,400 RPM instead of the 6,900 RPM Steve wanted. But it did make more than 750 horsepower. We'll model the engine at 7,400 RPM and adjust the lift down to a 420 thousandths intake lobe lift and check the power. Rick knew nothing about raised runner ports having higher velocity, but Steve gave Rick another try at a cam and explained what he had found about camming the All-Pro heads from his experience. The second cam worked as advertised and made 20 more horsepower than Steve's best at the time. For more on induction logic software, stop by our YouTube channel at youtube.com/rickjones5908 to view more induction logic videos. Hope you enjoyed the video, and thanks for watching.